help you out with this. Okay, so 158 should say dependent events right here. And so I need you to go a page back, and where I told you to write this down on 156, let's just cross it out, okay? Let's just get rid of that. Like, just make sure you do this, okay? I don't want you to get that wrong. So on 156, get rid of dependent events. And that question there, I may come back to it later, not right now, okay? So 156, get rid of that. And then you've got to make sure that on 158 you do have dependent events there, nice and big, so that when you go through it, you find it. And we're going to answer these questions that are just above it here. So 158, we're going to do that before I made a handout that I'm going to give you in a bit. Okay. That's it. All right. Alfred rolled a die twice. The first time it landed on a 5. What's the probability the second roll will be a 5 again? They're trying to trick you there. They're trying to say, hey, remember first event? First thing happened, it landed on a 5. What's the probability that the second, right, this is the second event, will land on a 5 again? Does it matter what you rolled before at all? Now, some of you say, oh, it's your lucky day, right? You got a couple of 6s, like, but actually, technically, it has nothing to do, unless you're superstitious. But your rolls before do not matter the next outcome, right? So they're trying to trick you here, and I will trick you too on a test or AC or whatever comes your way, right? So these are actually independent events. Independent, write that down, events, right? First, right, the first event does not affect the second event. First event does not affect the second event. And so dice will not, like dice, they're out of the question. They're not dependent, right? Because you're using the same dice over and over. Don't fall for it. So probability of a 5 again, let's write this down like that. Probability of 5 again is still 1 out of 6, right? Second roll. Let's go P5 again. Third roll, still 1 out of 6, and still at a 1 out of 6. It's never going to change. So I'm going to go dot 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 here. Right? It keeps on going. Fourth roll, it stays 1 out of 6. It doesn't change. I hope that makes sense. 5. A family consists of 3 children. The first 2 are boys. What's the probability of the third one being a boy? So this is biologically speaking, okay? This is not talking about, because nowadays we have to be careful, right? Like sexual orientation, whatever. Not referring to that. This is just biologically speaking, right? So when you're born, they look at the babies like, right? Like there's something there, that's a boy. If it's not, that's a girl. That's what we're coming down to, okay? So I'm not referring to anything else here. So if there's a family has 3 children, the first 2 are boys, what's the probability that the third one will be a boy? The answer is, regardless of the previous, I'm going to call this events, right? Regardless of the previous event, the probability of the third child being a boy is still 1 out of 2 or 50%, right? Like it doesn't matter how many kids that family has, technically, biologically speaking, every time there's a 50-50 chance of it being a boy or a girl. So again, independent events. Because I might ask you, tell me if this is a dependent or independent event. Just reading it, all you have to tell me is it dependent or is it independent? And in this case, it would be independent because whatever happens before does not affect the next. Una used the spinner below and landed on a heart. If she spins it again, what's the probability it will land on a heart? Still independent events, right? Independent events. First does not affect second. That's your rationale. That's your explanation, right? Spinning that wheel, getting a heart will not affect, it actually doesn't matter what you get the first time, it will not affect the second outcome. So probability of heart, look at that. Heart is still, what is it? 1 heart and another heart. So 2 out of 10, right? Second spin. I will say that. This is the second spin. First spin, probability of a heart is still 2 out of 10. And I want to make it so painfully obvious, like you're probably saying, I got it already, Mr. Drickson. I just want to make sure it sinks in so that you understand the difference, okay? And you will be able to tell what's happening here. Like you don't have to worry about dependent events all the time. When you read a question, it's like marbles. Oh, not putting it back. Okay, this is definitely a dependent situation, right? And so you need to be aware of that. So first spin is 2 out of 10, still 2 out of 10, right? Here, when we started to talk about dependent events, watch this. We had 4 out of 52, and then all of a sudden it was 4 out of 51. It changed, right? It changed. And we'll highlight that, right? 52, 51, right? That's when it starts changing, right? First event affects the second event. Okay. All right. I'm going to flip over. We did this probability involving letters scenario. And then I want you to write down here, C, independent versus dependent worksheet. I want you to have that there. Like if you're studying, you're like, hey, I got that. Now, oh, I'm going to go find that worksheet. And that's the one that I'm going to give you. And to cross-reference on here, we're going to write down C page 158 in our book, right? So that you can like take it, whichever one you find first is going to lead you to the other. So, so right on top of this, see page 158. want to make sure everybody got one. If you didn't get one, please let me know because I was just counting. Okay, top of this page, see page 158 and notes, right? Notes booklet. And to be specific, this is chapter 4, right? This is probability chapter 4. And the reason why I made this, I actually made this on that crazy Friday snow day, because I felt like the booklet never really had enough explanations on there. So I'm going to grab a highlighter. So on this handout, recall in some cases, the question will ask for the probability of an event, given that an event happened before. Okay. If events are independent, right? If events are independent, the second event is not affected by the first one. And then you have rolling dice, flipping a coin, spinning a spinner. If you want to put that down, right? A spinner would also not be affected. So nothing happens. The probability of rolling a 2 is always 1 out of 6, no matter how many times the die was rolled beforehand. Right? And dependent, right? When the outcome of the second event, is affected by an event that happened beforehand. Okay? The key word there is no replacement. And you're talking cards, marbles, letters in a bag, you name it. Something that actually diminishes, that you can take something and not put it back. You're affecting the outcome. Okay? You'll have to watch for 2 things. When it's dependent, you have to watch for 2 things. The total will go down by 1. The numerator will only go down if the previous event affects the number of desired outcomes. So the total will for sure be affected. The question is the top number going to be affected? That is the question. Okay, so suppose there's a bag of 15 marbles, 4 blue, 5 green, 6 yellow. First, a marble is drawn and not replaced. Then another marble is drawn. Fill in the diagram below. So we're kind of going to do a couple of these, and I'm gonna walk you through the first one. So probability of getting a blue at first, this is the first event, right? A marble is being drawn. So it's 4 out of 15 because we have 4 blue out of the 15. No, that one I think everybody can wrap their head around. Let's follow this arrow here. If there is replacement, if you're replacing the first one, what's the probability of getting a blue on the second draw? And the answer is it's the same, right? It'd be the same thing because you're replacing. Sorry. Nothing changed. This is an independent event. Independent events, the first event that happened did not affect the outcome of the second because there is a replacement. So I would actually maybe circle this. There is a replacement there. But what if, let's consider the second scenario, you draw a blue one. If there's no replacement, what's the probability of getting a blue the second time? So now the 15 will be reduced by 1. And you're talking blue here, so you used to have 4. Since you drew a blue one, this will go down by 1 as well. So that is actually 3 out of 14. right? Only 3 blue left. Total decreased by 1. Okay? No replacement. And then let's go another scenario. So let's go back and say, okay, first event, probability of blue, a blue is drawn, right? Not replaced. What's the probability of drawing a green the second time? How many greens do we have? We have 5. If you go up there, we have 5. That has not been affected because a blue was drawn first. That is not affected. But the total, 15, has gone down by 1 because there's no replacement. So this is 5 over 14. Only total has been affected. Only the total. So let's make an arrow making sure, right, that's the total there. This would be a dependent event. Dependent, dependent. And it all comes down to no replacement, okay? If it's no replacement, you're right away saying, okay, these are dependent events. Think about it. If you're independent, sooner, some of you already are. Some of you are going to turn 18, right? You're independent now, right? Like whatever your parents say has nothing, you're not necessarily going to follow it, right? So independent means like the first doesn't affect the second. You're on your own now. Okay. Let's try it again, and I'm gonna twist it on you, so you really have to put your thinking caps on here. So here we go. Try it again. So the first event, a marble is being drawn, and it's going to be yellow. Okay? Probability of drawing a yellow, we're still having 15 total. And if you look up, yellow, we have 6 of them. So that's 6 out of 15. So now we're starting from scratch, right? Then you follow this line here, which has replacement. So that's independent. Independent, nothing will be affected here. So probability of drawing a blue the second time, since you're putting it back, the 15 will not be affected. And you're putting it back, the blue has not been affected anyways because the first one was a yellow, this is a blue, so there's still how many blue? 4 blue left. So that's 4 out of 15. Okay, reverse now. This happens. Now we're going down this arrow. No replacement, dependent. Okay? So we know for sure that the total has gone down by 1. Guaranteed. So you get 1 mark right there. Because what you're looking for is blue. Has that been affected by the first event? And the answer is no, right? Because you were after the yellows and a yellow has been pulled. So blue is still 4. So that's that. And then the third option, let's rewind. The first event is happening, which is 6 out of 15. Then you go down this branch, no replacement, so this is dependent, which means, okay, let's put it this way. If it's dependent, the denominator will be affected, guaranteed. Okay, so you can say, okay, it's not being replaced, so we're down to 14. Score your 1 mark right there. Okay, since it was a yellow, the yellow that you're after will be affected. So this is, you used to have 6, we're going to go minus 1. So that's actually 5 over 14. This is what you're after. And so that's how this That's how I designed this. I designed you to think, what if it's independent where you replace it? What if it's dependent when you're not replacing? What if you're drawing two different colors? What if you're drawing the same color again? If you're drawing the same color again, both will be affected. Because you started at 6 out of 15, now it's 5 out of 14 the second time around. Could you imagine a third? Oh my goodness. I'm not going to do it now, but right, if you wanted another yellow, then this would be 4 and this would be 13, right? So as you're drawing the same color, both will be decreased because you could be drawing many times, right, if you wanted to. Back side here. I want you to try to fill this out, this tree here. Try to do that on your own. See if you can. Let's see how you did. So the first event, you want a green. I need to peek once. There are 5 of them. 5 out of 15. So you can reduce that to 1 out of 3, but we're not going to do that here. If your replacement, that's dependent, sorry, independent, because you're replacing it, right? So green again is still 5 out of 15. Nothing changes. There's independent situation again where you're replacing the first one. So probably your blue, the 15 is still the same. The blue has not been affected by green for sure. There are 4 of them, right? No replacement, this is dependent. So you know for sure that the total will go down by 1. Since the first one was a green, the amount of greens will also have gone down by 1. So that's that. And no replacement again, so this is dependent. So it's yellow. Because it's dependent, the total will have decreased. The green did not affect the number of yellows, so you can go back to the original amount of yellows, which is 6. Right now we're not focusing on reducing. That's not what we're focusing on today. This is just understanding the concept. So I hope this tree helped you to understand the difference between independent and dependent. Okay? Practice questions. I want you to try these, and that's going to be it for today, by the way, if you just do this. The only thing I don't want you to do, because I didn't get to it yet, is odds. Unless you know your odds, unless you know and remember that from before, because some of you know your, right, you understand how to work with odds, leave this for now, okay? So these 3 here on this worksheet, optional for now. We're going to come back to that later. But do all the other ones, please. And try to understand. So we're going deck of cards here, okay? It's not just, so it's not much, but try this right now, because tomorrow I'll just go over it quickly. And that'll be it, okay, for today.